Imagine this. You're standing at the edge of a portal, a gateway that could whisk you across the galaxy in mere seconds, as if you were stepping through a tunnel in the fabric of space and time. Sounds like something straight out of a science fiction movie, right? But here's the twist. This could actually be a real possibility, thanks to the mind-bending concepts of wormholes and quantum physics. The question is, do these cosmic portals truly exist? And if they do, how could the strange laws of quantum mechanics make them possible? Today, we're diving into the quantum secrets of wormholes and exploring how they might just revolutionize space exploration as we know it. In this video, we're going to take a deep dive into the theory of wormholes, uncover how quantum physics might explain their existence, and discover how they could potentially take us to the stars. Get ready for a journey that blends science, mystery, and a dash of futuristic wonder. But before we go any further, don't forget to hit that like button and subscribe to Exploring the Universe so you never miss out on more fascinating content about the incredible world of astronomy. Now let's set the stage. The idea of wormholes isn't just a modern invention, it has roots in the work of two of the greatest minds in physics, Albert Einstein and Nathan Rosen. Back in 1935, they proposed the concept as part of Einstein's theory of general relativity. They called them Einstein-Rosen bridges, and while they didn't exactly imagine them as cosmic shortcuts, their work laid the foundation for what we now think of as wormholes. Think of space-time as a vast, stretchy sheet. If you could fold that sheet so that two distant points touched, a wormhole would be like a tunnel connecting them. It's a shortcut through the universe, bypassing the need to travel the long way around. But here's where it gets even more fascinating. Some scientists believe that wormholes might not just connect distant places in space, they could also link different points in time. Yes, you heard that right. Wormholes might be the key to time travel. Now you might be wondering, how does quantum physics fit into all of this? Well, quantum mechanics is all about the strange, unpredictable behavior of particles at the smallest scales. One of the most intriguing ideas is that wormholes could be connected to quantum phenomena like entanglement, where particles can instantly affect each other no matter how far apart they are, and quantum foam, the turbulent, frothy nature of space-time at the tiniest levels. Some physicists even suggest that microscopic wormholes might pop in and out of existence all the time in the quantum realm. So could quantum physics hold the key to creating or sustaining a wormhole? One possibility lies in something called negative energy, a concept that defies our everyday understanding of physics. Negative energy could counteract gravity, preventing a wormhole from collapsing. But here's the catch. We don't yet know how to generate or harness such energy. As the renowned physicist Kip Thorne once said, wormholes are mathematically possible, but they require conditions so extreme that we're not even close to figuring out how to create them. Now let's dream a little. If we could find or create a stable wormhole, it could revolutionize space travel. Instead of spending thousands of years traveling to distant galaxies, we could hop through a wormhole and be there in an instant. Imagine the possibilities, exploring alien worlds, meeting civilizations from other stars, or even traveling through time. It's the stuff of dreams, but who knows? The universe is full of surprises. Of course, there are enormous challenges to overcome. Creating a wormhole would require unimaginable amounts of energy and technology far beyond what we currently have. Some scientists even speculate that advanced civilizations might already be using wormholes for interstellar travel. Could we one day join them? Only time will tell. So, what do you think? Will wormholes be discovered within this century? Could they be the key to unlocking the secrets of the cosmos? Let us know in the comments below, and don't forget to like this video and subscribe to Exploring the Universe for more mind-blowing explorations of the universe. Until next time, keep looking up, and who knows, maybe one day we'll be stepping through a wormhole together. Let's start by breaking it down. What exactly are wormholes? Imagine the universe as a giant, stretchy sheet of fabric. That's space-time. Now, if you could fold that sheet so that two distant points touch, a wormhole would be like a tunnel connecting them. It's a shortcut, a cosmic loophole that lets you skip the long journey across the universe. Instead of traveling billions of light years, you could step through this tunnel and emerge on the other side in an instant. Sounds like magic, right? But it's rooted in some of the most profound science we know. The idea of wormholes wasn't just pulled out of thin air, it has a fascinating history. Back in 1935, Albert Einstein and his colleague Nathan Rosen were exploring the implications of Einstein's theory of general relativity. They proposed something called an Einstein-Rosen bridge, which is essentially what we now call a wormhole. At the time, they weren't thinking about it as a shortcut for space travel. They were more focused on the math and the structure of space-time. But their work laid the groundwork for one of the most exciting concepts in modern physics. Now, here's where it gets really interesting. Wormholes aren't just about connecting two places in space. Some theories suggest they could also connect two different points in time. That's right. Wormholes might not just be portals across the universe, they could be portals through time itself. Imagine stepping into one end of a wormhole and emerging in a different era. It's a mind-bending idea, and it's one of the reasons wormholes capture our imagination so strongly. So let me ask you this. If you could step into a wormhole, what do you think you'd see? Would it be a swirling tunnel of light, a dark, endless void, or something completely beyond our imagination? Drop your thoughts in the comments. I'd love to hear your ideas. Now here's a little historical nugget. While Einstein and Rosen were the first to mathematically describe wormholes, the term wormhole itself was actually coined much later. It was physicist John Wheeler who in the 1950s came up with the name. He imagined space-time as an apple and a worm burrowing through it. Hence, a wormhole. It's a simple analogy, but it perfectly captures the essence of what a wormhole is. A tunnel through the fabric of reality. But here's the thing, wormholes aren't just science fiction. They're a legitimate scientific concept, even if we've never observed one. They're a reminder that the universe is far stranger and more wonderful than we can imagine. And who knows, maybe one day we'll find a way to create or discover one, opening up entirely new possibilities for exploration. So, what do you think? Could wormholes be the key to unlocking the secrets of the cosmos? Let's keep exploring, because the journey is just as exciting as the destination. Now let's dive into the quantum side of things. Because when it comes to wormholes, the connection to quantum physics is absolutely fascinating. You see, wormholes might not just be cosmic shortcuts, they could be deeply tied to some of the strangest phenomena in the quantum world. Phenomena like quantum entanglement and quantum foam. Let me explain. First, let's talk about quantum entanglement. This is the mind-blowing idea that two particles can become linked in such a way that whatever happens to one instantly affects the other, no matter how far apart they are. It's like they're having a secret conversation across the universe. Some physicists have suggested that entanglement might actually be connected to wormholes, that these particles could be linked by microscopic wormholes we can't see. It's a wild idea, but it's one that's gaining traction in the scientific community. Then there's quantum foam. Picture space-time not as a smooth, calm surface, but as a turbulent, frothy ocean. At the tiniest scales, space-time is constantly bubbling and churning, with tiny wormholes popping in and out of existence like bubbles in a boiling pot. These wormholes would be unimaginably small, far smaller than an atom, but they're a reminder that the fabric of reality is far more dynamic than we usually think. Here's a fun analogy to help you visualize this. Imagine space-time as an ocean. On the surface, it might look calm and steady, but if you zoom in, you'll see waves, currents, and even tiny bubbles forming and popping. Those bubbles? They're like microscopic wormholes, constantly appearing and disappearing in the quantum foam. It's a chaotic, ever-changing landscape, and it's one of the most intriguing aspects of quantum physics. Now here's a little curiosity to blow your mind. Some physicists believe that these microscopic wormholes might not just be theoretical, they could actually exist at the quantum level. We're talking about wormholes so small that they'd be impossible to see with any technology we have today. But if they're real, they could be everywhere, woven into the very fabric of space-time. It's a humbling thought, isn't it? That the universe might be filled with tiny tunnels we can't even perceive. So, what does all this mean? It means that wormholes aren't just about bending space-time on a cosmic scale. They're also deeply connected to the weird, wonderful world of quantum physics. And who knows, maybe one day we'll find a way to harness these quantum wormholes, unlocking new possibilities for science and exploration. What do you think about this quantum connection? Could microscopic wormholes be the key to understanding the deeper mysteries of the universe? Let's keep exploring, because the more we learn, the more we realize just how much we still have to discover. All right, let's get into the nitty-gritty. How could quantum physics actually sustain a wormhole? Because here's the thing, wormholes, as fascinating as they are, have a major problem. They're incredibly unstable. If you tried to create one, it would likely collapse almost instantly under its own gravity. But there's a potential solution, and it comes from the strange world of quantum physics: negative energy. Negative energy might sound like something out of a sci-fi movie, but it's a real concept in physics. Unlike the energy we're used to, the kind that powers stars, planets, and even our own bodies, negative energy has the opposite effect. It repels rather than attracts. And here's where it gets interesting. Negative energy could counteract the immense gravitational forces inside a wormhole, preventing it from collapsing. Think of it like a cosmic balancing act. Gravity pulls the wormhole inward, while negative energy pushes back, keeping it open. Now let's break this down a little further. In the quantum world, particles and energy aren't always constant. They fluctuate, popping in and out of existence in what's known as the quantum vacuum. These fluctuations can create tiny amounts of negative energy. Some physicists believe that if we could somehow harness and amplify this negative energy, we might be able to stabilize a wormhole. It's a long shot, but it's not impossible. Here's where an expert opinion comes in. Kip Thorne, one of the most respected theoretical physicists of our time, once said, "Wormholes are mathematically possible, but they require conditions so extreme that we're not even close to figuring out how to create them." And he's right. The amount of negative energy needed to keep a wormhole open would be staggering, far beyond anything we're capable of producing today. But the fact that it's mathematically possible gives us hope. Now here's a little historical tidbit. The idea of using negative energy to stabilize wormholes was first seriously explored in the 1980s, during a surge of interest in the physics of time travel and exotic phenomena. It was around this time that Kip Thorne, along with other physicists, began to seriously consider whether wormholes could be more than just theoretical curiosities. Their work laid the foundation for much of what we know, and what we're still trying to figure out, about these cosmic tunnels. So, what does all this mean for the future? It means that while we're not yet capable of creating or sustaining a wormhole, the science isn't ruling it out. Negative energy might just be the key to unlocking this incredible possibility. And who knows, maybe one day we'll crack the code and open up entirely new realms of exploration. What do you think? Could negative energy be the missing piece of the wormhole puzzle? Let's keep dreaming, keep exploring, and who knows, maybe one day we'll find a way to make the impossible possible. Now let's talk about the big dream. The one that makes wormholes so irresistible to scientists, storytellers, and dreamers alike: interstellar travel. Imagine this. If we could create or discover a stable wormhole, it could take us to other galaxies in a matter of seconds. No more spending thousands of years traveling across the vast emptiness of space. Instead, we'd step through a cosmic shortcut and emerge on the other side of the universe. It's the ultimate sci-fi fantasy, but it might not be as far-fetched as it sounds. Here's the thing, wormholes wouldn't just connect distant places in space. In theory, they could also connect different points in time. That's right, wormholes might not just be portals across the universe, they could be portals through time itself. Imagine stepping into a wormhole and emerging in a different era, maybe the distant past, or even the far future. It's a mind-blowing idea, and it's one of the reasons wormholes have captured our imaginations for decades. So let me ask you this, if you could travel through a wormhole, where or when would you go? Would you visit a distant galaxy, explore an alien world, or travel back in time to witness a pivotal moment in history? Maybe you'd go forward to see what humanity achieves in the centuries to come. Drop your answers in the comments. I'd love to hear your wildest wormhole travel dreams. Now, here's a little curiosity to spark your imagination. Some scientists believe that wormholes could be part of a vast cosmic network, connecting not just different places and times, but even different universes. It's a concept straight out of science fiction, but it's rooted in some serious theoretical physics. The idea is that our universe might be just one of many, and wormholes could be the bridges that link them together. It's a humbling thought, isn't it? That there might be entire worlds out there waiting to be discovered. Of course, all of this raises a big question. Will we ever actually find or create a stable wormhole? Will it happen in this century, or will it remain a distant dream? I'd love to hear your thoughts. Do you think wormholes will be discovered in our lifetime? Let me know in the comments, and don't forget to hit that like button if you're enjoying this journey through the cosmos. Here's the thing, whether or not we ever find a wormhole, the idea of them pushes us to think bigger, to dream bigger. They remind us that the universe is full of possibilities we haven't even begun to explore. And who knows? Maybe one day we'll unlock the secrets of wormholes and open up entirely new frontiers for humanity. So, what do you think? Are wormholes the key to interstellar travel, or are they just a tantalizing dream? Let's keep exploring, keep questioning, and who knows, maybe one day we'll find ourselves stepping through a wormhole, ready to discover what lies on the other side. Now, let's get real for a moment. As incredible as wormholes sound, there are some massive challenges standing between us and the ability to create or use them. The first and most obvious hurdle: energy. Creating a stable wormhole would require amounts of energy so absurd, so unimaginably vast, that we don't even have the technology to think about generating it. We're talking about energy levels that dwarf anything we've ever produced, even the energy released by the most powerful supernova in the universe. Here's the thing. Wormholes aren't just holes you can poke into space-time. They're incredibly delicate structures that would require precise conditions to stay open. Gravity would constantly be trying to crush them, and without something to counteract that force, like the negative energy we talked about earlier, they'd collapse almost instantly. And right now, we have no idea how to create or harness the kind of energy needed to keep them stable. Now, here's a fascinating thought. Some scientists have speculated that advanced civilizations, ones far beyond our current level of technology, might already be using wormholes for interstellar travel. Think about it. If a civilization had mastered the ability to generate and control the immense energy required to create wormholes, they could essentially have a galactic highway system connecting distant stars and planets. It's a tantalizing idea, and it raises all sorts of questions. Could there be civilizations out there zipping through wormholes right now while we're still figuring out how to get to Mars? Here's a little historical context. The idea of wormholes as a means of travel really took off in the 1980s when physicists like Kip Thorne began exploring the theoretical possibilities. Thorne even consulted on the movie Interstellar, helping to shape its portrayal of wormholes in a way that was as scientifically accurate as possible. It's a great example of how science and storytelling can inspire each other, pushing us to imagine what might be possible. But let's not sugarcoat it. The challenges are enormous. Beyond the energy requirements, we'd also need technologies that don't exist yet. We'd need to figure out how to manipulate space-time itself, how to create and control negative energy, and how to navigate the potential dangers of traveling through a wormhole. It's a tall order, to say the least. So where does that leave us? For now, wormholes remain a tantalizing possibility, one that's mathematically sound but practically out of reach. But here's the thing. Science is all about pushing boundaries. Every great discovery started as an impossible dream. And who knows, maybe one day we'll crack the code and unlock the secrets of wormholes, opening up the universe in ways we can't even imagine. What do you think? Could wormholes become a reality in the distant future, or are they destined to remain a fascinating idea? Let's keep dreaming, keep exploring, and who knows, maybe one day we'll find ourselves stepping through a wormhole, ready to discover what lies on the other side. Now let's venture into the realm of alternative theories and scientific debates. Because when it comes to wormholes, the conversation doesn't stop at space-time shortcuts. Some physicists have proposed that wormholes might actually explain some of the universe's biggest mysteries. Take dark matter, for example. We know it's out there. It makes up about 85% of the matter in the universe, but we still don't know what it actually is. Could wormholes be part of the answer? Here's the idea. Some researchers suggest that wormholes, especially microscopic ones, could be woven into the fabric of space-time, contributing to the gravitational effects we attribute to dark matter. It's a bold theory, and it's far from proven, but it's a reminder that wormholes might play a bigger role in the cosmos than we've even begun to understand. They could be hidden threads, connecting and shaping the universe in ways we're only starting to imagine. Now, here's where an expert opinion comes in. The legendary Stephen Hawking once said, "Wormholes may be part of a cosmic network that connects the entire universe." Think about that for a moment. If Hawking is right, wormholes might not just be isolated tunnels. They could be part of a vast, intricate web, linking everything from galaxies to particles. It's a breathtaking idea, and it's one that challenges us to think about the universe in a whole new way. Let's take a step back and look at the bigger picture. Wormholes aren't just about travel or shortcuts. They're about understanding the fundamental nature of reality. They force us to ask big questions. What is space-time? How does the universe hold itself together? And what other secrets might be hidden in the fabric of reality? Here's a little historical context. The idea of wormholes as part of a cosmic network isn't new. It's been floating around in scientific circles for decades, often tied to theories about quantum gravity and the structure of the universe. But it's only in recent years, with advances in technology and theoretical physics, that we've been able to start testing these ideas, even if only in simulations and thought experiments. So, what does all this mean? It means that wormholes aren't just a cool idea, they're a gateway to deeper understanding. Whether they're explaining dark matter, connecting the universe, or something else entirely, they're pushing the boundaries of what we know and what we're capable of discovering. What do you think? Could wormholes be the key to unlocking some of the universe's greatest mysteries? Let's keep the conversation going, keep exploring, and who knows? Maybe one day we'll find that wormholes are even more incredible than we've ever imagined. All right, let's talk about the cutting edge. What's happening right now in the world of wormhole research? Because while wormholes might still feel like science fiction, scientists are working hard to bring them into the realm of science fact. How? By using some of the most advanced technology we have, supercomputers and quantum computers. Here's the deal. Simulating wormholes is no easy task. You're dealing with the complexities of space-time, quantum mechanics, and gravity all at once. That's where supercomputers come in. These powerful machines can crunch mind-boggling amounts of data, allowing scientists to create virtual models of wormholes and test their properties. It's like building a wormhole in a lab, except it's all happening in the digital world. These simulations are helping researchers understand how wormholes might form, how they behave, and whether they could ever be stable enough to use. Now, here's where it gets even more exciting. In 2022, a team of physicists made headlines by creating something called a holographic wormhole using a quantum computer. It wasn't a real wormhole, of course. It was a simulation that mimicked the behavior of a wormhole using quantum entanglement. Think of it as a kind of cosmic dress rehearsal, giving us a glimpse of how wormholes might work in the real world. It was a groundbreaking experiment and a major step forward in our understanding of these mysterious phenomena. Let's put this into perspective. Just a few decades ago, wormholes were purely theoretical, something you'd only find in the pages of a physics textbook or a sci-fi novel. But now, thanks to advances in technology, we're starting to test these ideas in real, tangible ways. It's a reminder of how far we've come and how much further we still have to go. Dad, here's a little curiosity to spark your imagination. Some scientists believe that wormholes could be the key to unlocking the secrets of quantum gravity, the holy grail of modern physics. By studying wormholes, we might finally find a way to unify Einstein's theory of relativity with the strange world of quantum mechanics. It's a huge challenge, but it's one that could revolutionize our understanding of the universe. So what does the future hold? Will we one day create a real wormhole, or will they remain a tantalizing idea, forever just out of reach? Only time will tell. But one thing's for sure, the journey to understand wormholes is just as exciting as the destination. What do you think? Are we on the brink of a major breakthrough, or is the mystery of wormholes destined to keep us guessing? Let's keep exploring, keep dreaming, and who knows, maybe one day we'll find ourselves stepping through a wormhole, ready to discover what lies on the other side. Now get ready for something that will blow your mind. What if I told you that wormholes might not just be portals to other parts of our universe, but could actually be gateways to other universes entirely? Yes, you heard that right. The multiverse theory, one of the most mind-bending concepts in modern physics, suggests that wormholes could serve as bridges between parallel realities. Think about that for a moment. We're not just talking about traveling across our own universe anymore. We're talking about the possibility of traveling between different versions of reality. Imagine a universe where dinosaurs never went extinct, or where humans evolved differently, or where the laws of physics themselves are slightly different. According to some theoretical physicists, these parallel universes might not just be science fiction, they could be real, and wormholes might be the key to reaching them. The idea of parallel universes isn't new. Back in the 1950s, physicist Hugh Everett proposed what we now call the many worlds interpretation of quantum mechanics. He suggested that every time a quantum event occurs, reality splits into different branches, creating countless parallel universes. It sounds crazy, but here's the thing. The math behind it actually works. And this is where wormholes come in. Some scientists believe that these cosmic tunnels might naturally form connections between different universes in the multiverse. It's like having a network of cosmic highways, not just within our universe, but between different versions of reality. The implications are staggering. We might be living in just one universe among an infinite number of others, all potentially connected by a web of wormholes. But here's the big question that keeps physicists up at night. Are we getting close to uncovering the deepest secrets of the cosmos, or will wormholes remain one of physics' most fascinating mysteries? The more we learn about quantum mechanics and the nature of space-time, the more questions we seem to have. Each answer leads to new puzzles, new possibilities, and new frontiers to explore. Think about where we were just a century ago. Einstein had just proposed his theory of relativity, and the idea of wormholes was barely a mathematical curiosity. Now, we're running quantum simulations of wormholes and seriously discussing the possibility of parallel universes. What might we discover in the next 100 years, the next 1,000? The possibilities are as endless as the multiverse itself. What do you think? Could we really be on the verge of discovering pathways to other universes, or is this just another beautiful dream born from our endless curiosity about the cosmos? Let me know your thoughts in the comments below, because in the end, it's questions like these that drive us forward, pushing the boundaries of what we think is possible and reminding us that the universe, or should I say universes, might be even stranger and more wonderful than we ever imagined. As we reach the end of our cosmic journey today, let's take a moment to reflect on the incredible territory we've covered. We've explored how quantum physics might not just explain wormholes, but could actually be the key to making them possible. We've ventured through the mind-bending implications of interstellar travel and faced head-on the enormous challenges that still lie ahead. From Einstein and Rosen's groundbreaking work in 1935 to today's cutting-edge quantum simulations, we've seen how our understanding of wormholes has evolved. We've learned how negative energy might keep these cosmic tunnels open, how quantum entanglement might be connected to them, and how they might even be woven into the very fabric of space-time itself. But perhaps the most exciting thing about wormholes is not what we know, but what we have yet to discover. Every time we think we've figured something out about the universe, it surprises us with something even more amazing. Just like the astronomers of ancient times who gazed up at the stars and dreamed of reaching them, we're now looking at the mathematics of wormholes and dreaming of shortcuts through space and time. The universe is like a vast cosmic puzzle box filled with mysteries waiting to be solved. Wormholes are just one piece of that puzzle, but what a fascinating piece they are. They challenge our understanding of physics, push the boundaries of our imagination, and remind us that the impossible might just be possible after all. Who knows? Maybe one day future generations will look back at this time as the beginning of humanity's greatest adventure. Maybe they'll be stepping through wormholes as easily as we step through doorways, exploring distant galaxies and unlocking the secrets of the cosmos. The journey to that future starts with curiosity, with asking questions, with daring to imagine what might be possible. I want to thank you for joining me on this exploration of one of the universe's most fascinating mysteries. If you've enjoyed this journey through the quantum nature of wormholes, why not join me for more cosmic adventures? Hit that subscribe button to become part of our growing community of space explorers and cosmic dreamers. Turn on notifications so you never miss out on our next journey through the wonders of the universe. Don't forget to leave a like if you enjoyed this video and share it with anyone you know who loves to ponder the mysteries of the cosmos. You can also follow Exploring the Universe on social media for daily doses of cosmic curiosity and behind-the-scenes looks at the making of these videos. Until our next cosmic adventure, keep looking up at the stars, keep asking questions, and keep wondering about the mysteries that await us out there in the vast expanse of space. Because somewhere, in the infinite depths of the cosmos, wormholes might be waiting to show us the way to the stars. This is Exploring the Universe, signing off. See you in our next cosmic journey through space and time.